Good morning, student. Is my voice audible? So anyone please confirm me, is my voice audible?
Audible, madam.
Thank you, sir. Okay. Today, so I will again come with some other set. Thank you, Swati. Again, I will come with some other set of problems. Okay. Let me move on to the skip my screen. Okay. So this is the problem. This is your textbook exercise problem. Okay. So the following grammar. So very pretty. Here they have given the input as a grammar. So no need to write the grammar for the regular expression. Okay. So the regular expression as well as the grammar for the regular expression both are given as input. Okay. So the following grammar generates the language of the regular expression 0 star 1 0 plus 1 closer. And so this is the regular production rules. Give leftmost and rightmost derivations for the of the following strings. Okay, you have to you have to find the leftmost and rightmost derivation for each strings. Okay, there are three strings they have given. So I will start with the first string. Okay, A part. So what's the string? 00101. Okay, so this is the string. So first I will write leftmost derivation. Okay. One of the easiest part in the unit 3. Okay, so leftmost derivation. So I will start with start here the yes, which is act as a start symbol. So I will start with yes. So yes, A 1B. So our goal is to reach 00101. So our goal is to derive the particular string. Okay. So since I'm following leftmost derivation, the leftmost non-terminal which has been replaced first. Okay. So here, what is the leftmost non-terminal? Post in the chat box. What's the leftmost non-terminal? So in the screen, yes, leftmost. Actually, so for you, the leftmost here, which is A, okay, rightmost only B, okay. So leftmost, don't forget here, leftmost means A, okay. So rightmost, which is B, okay. So I will replace A first, okay. So I'm trying to replace the A first. So I will choose, actually, there are two options for A. A can be replaced by 0A or epsilon, okay. But here I will choose 0A. For rightmost derivation, you will tell the answer. Because I will replace for A as 0A. Okay. A is replaced by 0A. Then again, I will write 1B as it is. First step over. In the next step, see that at a time, we can replace one non-terminal at a time. Okay. So see next, I will choose again. There are two non-terminals available. So I will choose A, which is the leftmost symbol variable. Okay. So again, instead of A, I will replace 0A. So 0. So instead of A, I will replace 0A. Okay. So 1B. So kept 1B as it is. Next, so again, two variables. So A and B. So I will choose A. So instead of A, I will choose here epsilon. Okay. 0, 0. For A, I will choose epsilon. So no, don't need to write epsilon here. Okay, 0, 0, 1B. Okay, so only one non-terminal, that is variable is available. So instead of B, I will choose any one production rule. Actually, three rules are available. Okay, first I will choose 0B. For instead of B, first I will choose 0B. It's typically based on your choice. You have to pick a right choice at the right place. So for B, so I will choose 0B. Again, B is the, okay. So for that B, I will choose 1B. 0, 0, 1, 0. So I will so replace B, which is 1B. Okay. I will instruct you all students take a paper and work out in parallel. For rightmost tree, you will tell me the answer. So 0, 0, 1, 0, 1. See here 0, 0, 1, 0, 1. So almost the string is reached 0, 0, 1, 0, 1. So instead of B, I will choose epsilon. Okay, so 0, 0, 1, 0, 1. Okay, finally we have received the respective string. Okay, 0, 0, 1, 0, 1. This is the given string. That string is derived. Okay, so our choice is correct. Okay, so this is the way how to rightmost derivation. Okay, so again, all of you take a paper. So, so try to execute rightmost derivation. Okay, so leftmost derivation move on. Next, rightmost derivation. So again, starting with the starting symbol, S tends to A, 1, B. Okay, so two variables are available. So you have to choose first B, since it is a rightmost derivation. Okay, so for A, 1, so instead of B, what will be your choice? So instead of B, you have to replace the production rule. Okay, which one is the suitable one? For B, you can choose either 0B, 1B, epsilon. Three production rules are available. Yes, 0B. Thank you. So instead of B, so choose 0B. Okay. So again, you have to two variables. So rightmost, which is B. So instead of B, so your choice. What will be your choice for this case? Yes, 1B. So I will choose 1B instead of B. Okay. So again, B is A and B is the, so for your choice for B, epsilon. Good. So B is replaced by epsilon. So the remaining things, keep it as it is. A, 1, 0, 1. Okay. So next, A. So instead of A, what will be our choice? So only one variable is available, A. So you have to replace A. Yes, 0A. Okay. So for A, based on your choice, we will choose 0A, 1, 0, 1. Okay. So for this A, what will be your choice? Yes, 0A. Okay. So for this A again, we will choose 0A, 1, 0, 1. Okay. So only one is 1A. So for what about this A? Epsilon. Yes. So already almost this string is available 0, 0, 1, 0, 1. Okay. So I will almost reach the string. So instead of A, so you have to replace A with epsilon. So 0, 0, 1, 0, 1. Okay. So this is our string. So the string is reached to our production rule. The production rules are the right one. Okay. So next 1 0 0 1. Okay. So next problem, string 1 0 0 1. Leftmost derivation first. The same production rule. Yes, tends to A 1B. So what will be your choice? You have to choose A or B. A, right. Okay. So for A, we choose 1A, right? 1A. Okay. Based on your choice, I will choose 1A. For A, which is replaced by 1A. Okay. So 1A, 1B. So I will not tell this is the one way of deriving the string. Almost there are n number of ways is possible. So for this A, what will be your choice? I will move with your choice only. 0A. 0A. Okay. So for this A, we will choose 0A, 1B. Okay. Okay. Next for A, for this A, again 0A. Okay. Again 0A. 1, 0. So again 0A. If it is 0A, okay, 1B. Okay. Okay. For this A, epsilon. Epsilon. Okay. So epsilon means so remaining part. We'll write the remaining part, right? Again, very simple. Again also for B also epsilon, right? So 1, 0, 0, 1. Good. Okay. Next, rightmost derivation. So again, starting with A, 1B. So compare with your second part, pushed on automata, which is the very easiest part. Okay, which will helpful for you to get pass mark in any three than pushed on. Okay, which is the your choice? A or B? Yes, B. Okay, instead of B, what will be your choice? Only two students are answering. What about others? So hereafter, yes, we will give the marks, internal marks based on your interactions on the class. Okay, actually that will be the good choice. Okay, for B, we choose 1B. Okay, so for B, we choose 1B. Next for B, 0B. Okay. So hereafter, I will write the name who will interact the session. Write the name and make a separate Excel file. Okay, it will helpful for giving you more marks in internals. Okay, for B, 0B. Okay, for B, 0B. Okay, for B, wrong. It's coming wrong. Yes, it's coming wrong. Yes. So, so I will choose first. Where it is? A, 1. So instead of B, so I will choose 0 B first. Okay. Instead of B, I will choose 0 B. Then again A, 1, 0. So instead of B, I will choose 0 B. Okay. So next A, 1, 0, 0. So instead of a B, so I will choose 1B. Okay. So next epsilon. So A, 1, 0, 0, 1. Next for A, so I will choose epsilon. 1, 0, 0, 1. Okay, so this is also one way of deriving. Okay, I'm not telling you this is the one way of deriving. One or more ways are there. Okay, so this string is which is almost over. Shall I move next? Shall I move next? Next string. Okay, thank you. Triple zero double one. The C pod triple zero double one. Okay, this is the string first leftmost derivation. Okay, I will start as usual. S tends to A 1B. Okay, I will move with your choice. Okay, for A has been replaced by 0A. So, okay, 0A. 0A 1B. Next, for A, this A, again 0A. Okay, okay. For this A, again 0A. Okay, for this A, epsilon. Okay, okay. For this B, then for B, 1B. Okay, okay. For this B, epsilon. Good. Almost our string is reached. With respect 0, triple zero, double one. Yes, good. So leftmost derivation over. Next for rightmost derivation. So S tends to A 1B. For B, what will be your choice? For B, 1B. Okay. Next, for this B, epsilon. Super. So for this A, 0A, right? So again for this A, 0, again 0A. So again for this A, again 0A. For this A, again epsilon. Okay, almost the string is reached. Okay, so this problem is almost over. Okay, this is your textbook problem, very easy one. Okay. So the derivation part, leftmost derivation, rightmost derivation. So almost the derivation part which is over. Next set of problem. Parse tree. Next. Okay. What's the other name for the parse tree? What's the other name for the parse tree? Syntax tree, yes. Then derivation tree. Okay. So syntax tree, from the name itself, you can guess the second phase of compiler syntax analysis. So for making the analysis, the syntax tree, which will play a major role. Okay. So parse tree. This is the definition of parse tree. Parse trees are an alternative representation to derivations, right? It is an alternative representation of derivations. You know, derivations and the type of derivation, leftmost, rightmost. So it is a hierarchical structure. Okay, so it is a tree-like hierarchical structure which represents the derivation of the grammar, and yield. Yield means the output of the parse tree. Okay, I will show you the example. Same like leftmost derivation, rightmost derivation. The same like parse tree also coming to the two category: leftmost, left parse tree, right parse tree. Okay, so because parse tree is nothing but a diagrammatic representation of derivation. Okay, this is the production rule. Okay, so construct very simple one. So construct parse tree for this production rule. So here there is no they have given just the production rule. Okay, so they won't give any string. Okay, so I will choose your choice. So typically your choice, you can choose either the production of these three: ss star, ss plus, or a. So first I will choose ss star. Okay. This is not a problem actually. This is a way. Just let me know just how to construct a parse tree for the given production rule. For yes means yes, yes star. Okay. So for this yes is going to, I will choose for this yes, which is replaced by again yes, yes plus. For this yes, I will choose a. Okay, star. And this yes, I will choose a. For this yes, also I will choose a. This is based on my choice. Okay. Here, this is not a problem. This is a way of how to construct a parse tree for the given production rule. Okay. So see here, the last leaf node. Okay, so, I can't go further, right? Because that leaf nodes are replaced by the terminals. Okay, so here what are all the terminals? Terminals are a plus multiplication. These are all the terminals. Okay, so here only one non-terminal, yes. Since see your parse tree, your all leaf nodes are replaced by terminal. Yes, there is no way to move further. So this is called yield. Just for 2 mark, it will make helpful. This is actually replaced by, this is actually plus. Okay. C A plus A multiplication. This is the yield of this parse tree. Okay. So here one technical term, yield. Okay. So here what is the yield of this parse tree? A plus A multiplication. Okay. This is called yield of the parse tree. It will make helpful for the 2 mark. What do you mean? The yield means you have to write this you have to draw this diagram. Okay. So yield is nothing but the concatenation of the labels of the leaves. Okay. So in left right order. Okay. So order means left right order. Okay. It's called the yield of the parse tree. The concatenation of the labels of the leaves in left right order is called the yield of the parse tree, which is the definition of yield. Okay. Next, again the types of parse tree are types of derivation tree. So left derivation tree or left parse tree means it is based on the leftmost derivation. Okay, so right derivation tree means it is based on the rightmost derivation. Okay, so for example, this is the example: generating the string. They got here the input are a string. You have to generate the string by constructing the parse tree. The production rules are here. Okay, so you are constructing, you are going to construct left derivation tree as well as right derivation tree, or left parse tree or right parse tree. Okay, for this string they have given the input as a b a. Okay, so first you have to draw left derivation tree. for left derivation tree. Uh, See, this is the string A B A. Okay, so I will choose first yes. Okay, pick your production rule. Be very careful. So I will choose here A double S. A double S. This is my choice. Okay, let me check whether it will be comes in the right way or not. Okay, so I will choose yes tends to A double S. Okay, since it is the leftmost read, there are two non-terminals are here. Two means yes, yes. So since it is the left, I will choose the leftmost variable. Yes, this yes. Okay, this yes, which is replaced by. So I will choose A. So like derivation tree, it is based on your choice. Okay, so I will choose here A, then A, then yes. I will choose A, yes. Okay, here also two non-terminals are here. A, yes. Okay, for this, what are the production rule? See here for yes means yes BA or BA. There are two production rules. Okay, yes BA or BA. See here I will choose BA. Okay, so BA. Okay, so I will choose BA. For this yes I will choose again A, yes, yes. Okay, so next step I will replace X which is epsilon. Okay, this yes which is replaced by epsilon, and this yes which is also replaced by epsilon, and this yes which is also replaced by epsilon. See the yield A, A, B, A, A. So what is our string? Double A, B, double A, right? The yield is received. So this is also one of the right way to proceed. So this is the yield A, B, then A. Is the remaining part are replaced by epsilon. So no need to cover. Okay. This is the yield of this tree. The yield is nothing but it's our string. Double A, B, double A. Okay. It has been arrived. So since this is the right one. Next, I will draw rightmost derivation tree. Right derivation tree. So here I will start with again yes. I will choose for yes the same one A, yes, A, yes, yes. Okay. Next, this is the right derivation tree. So I will choose here yes, yes going to be replaced by A, A, yes. Okay. I'll make it in draw circle. This is also your choice. So I will move based on my choice. Okay. Yeah. So yes, yes. So I am again. So I will choose the rightmost yes. So yes, for yes, I will choose replace yes by this production. A, yes, yes. Okay. A, yes, yes. This yes which is replaced by epsilon, and this s which is also replaced by epsilon for this A. Okay, so I will choose here BA, BA. Okay, so for this yes which is also replaced by epsilon C double A 1B double A. The string is reached. Okay. See double A, so 1B double A. This is the yield of this parse tree, the string which is double. So what is our input string? Double A B double A. Okay. So this is also right one. So this is the way of how to draw leftmost or rightmost derivation tree. Okay. So parse tree. So what do you mean by parse tree? Parse tree, which is a hierarchical representation of a derivation. Okay. Next. Next part. So one of the problematic situation in the parse tree, or so one of the problematic situation in the grammar. Okay. See, that is ambiguity grammar. So one of important topic, one of the most important topic in first part of unit 3, ambiguity grammar. Okay. So what do you mean by ambiguity grammar? This is the definition. Okay. A grammar is said to be ambiguous if there exists two or more derivation tree for a string W. Okay. A grammar is said to be ambiguous if there exists two or more derivation tree for the same string W. Okay. So that is two or more derivation tree, which means if we can able to draw two two or more left derivation tree, okay, for a string, okay, for a string, if you can able to draw two or more left derivation tree, or two or more right derivation tree, or left and right derivation tree, means that is called a particular grammar which is ambiguous. Ambiguity. Okay, that problem which is raised here is ambiguity. Okay, so so our goal is to making a grammar which is unambiguous. Okay, so you have to remove the ambiguity. That is the problem. That how to remove this ambiguity. These concepts will cover into the next semester subject, compiler design. Okay, how to remove the ambiguity, because you have to remove the ambiguity, then only that particular program is compiled exactly. Okay, so at the compilations there should be only one compilation code should be generated. It won't be more than one code, it should be only one compilation code. That is why you have to remove ambiguity from the grammar. Okay, so that part which is almost a part B part, which is comes to the next semester in compiler design. For this TOC, you have to enough to know about ambiguity grammar. Okay, so ambiguity means if we can able to draw more than one left or more than one rightmost derivation tree for a particular string, means the particular grammar production rule which is ambiguity. Okay, so this is one definition, and one more definition, which is a grammar is said to be ambiguous if there exists more than one leftmost derivation, or more than one rightmost derivation, or more than one parse tree for the given input string. Okay, which is also another definition for ambiguity. Next, we will show the ambiguity problem. This is the example. Okay, see here, for this, the context-free grammar, the grammar is given in the form of tuples. So, yes, which is the non-terminal, A, B plus multiplication, which is the set of terminals in your grammar, P, production rules, S, starting state. Okay. So, this is the form of tuples, G equal to BTPS or NTPS. Okay. So, where production rule consists of, these are the production rule. Okay. So, um, first you will try to draw left derivation tree. Okay, so we'll try to draw left derivation tree. Since here there is no any string is available. Okay, so I will choose a string A plus A multiplying with B. See here, this is the grammar is nothing but the basic arithmetic operation for plus and multiplication. Okay, so this is the string I have chosen. Before writing the draw the parse tree, first I will write leftmost derivation. Okay, if your marks is more than 2 means, or if it is 4, or if it is 10 marks means, before constructing parse tree you have to write the particular derivations. Okay, then only the content should be elaborated. It's more than space is enough. Okay, yes. first leftmost derivation. So this is leftmost derivation. S tends to S plus S. I will replace S by A. Then again A plus S, which is removed by S multiplying with S. Again A plus A multiplying with S. A plus A multiplying with B. Okay. So yes, the string is reached A plus A star B. So I have to draw the respective parse tree. So I will choose first S plus S, right? Okay. So for S again I will choose uh, S is replaced by A. For this S, this is going to be replaced by S multiplying with S. So this S which is replaced by A and this S which is replaced by B. Okay. See here, this is the yield. A plus A star B, right? This is the yield. Next for rightmost, so rightmost derivation. So I will choose S multiplying with S. Then uh, S multiplying. If I choose S instead of S plus S means which is wrong, right? See here, I'm not writing rightmost derivation here. See, sorry, this is the way of proving. I'm trying to derive another leftmost derivation. Okay, this is the leftmost derivation one way. I will try to write another leftmost derivation. This is part two. Okay. If there are more than one leftmost tree means it is also coming to the ambiguous part, right? So another one leftmost derivation. For this, I will choose S multiplying with S. Again, which is left. So S plus S is replaced by S multiplying with S. Then for this S replaced A plus S multiplying with S. And for this S which is replaced by A. Okay, for this S I will replace B. Okay, this is one more way of how to derive using same leftmost derivation. Okay, so I will draw one more parse tree for the same leftmost tree. Yes, yes, which is replaced by S multiplying with S. This S which is leftmost. So this S which is replaced by S plus S. Okay, this S which is replaced by A, and this S which is also replaced by A, this S which is replaced by B. Okay, see the yield A plus A multiplication with B. Okay, see here for the same string. What is the string here? A plus A star B. Okay, for this string, here you have to can able to construct more than one derivation tree. See, this is the first which is different from these two. Both are not same. Okay, if both are same means the grammar is unambiguous grammar. Okay, if both trees are same means both the leftmost trees are same means the grammar is unambiguous. But here the trees are different. Okay, you can do verify. The trees are completely different. The first tree is completely different from second tree. So our conclusion is two derivation tree. In particular, two leftmost derivation tree for the same grammar. This is the conclusion. Two left two leftmost or left derivation trees for the same grammar or same string. Okay, as the given grammar is ambiguous. Ambiguous grammar. This is the one way of proving ambiguity. Okay. Another way means you can draw two derivation tree for rightmost. Okay. This is also another way of proving. Okay. And one way of the third way, which is you can draw one leftmost and you can draw one rightmost. Okay. If both are different means again the grammar is ambiguous. Okay. if if it is same means in all ways in left one or more left derivation tree all the parts trees are same as well as one or more in the rightmost derivation tree all the parts trees are same as well as leftmost and rightmost parts trees are same means the grammar is unambiguous grammar. Okay, else the grammar is the problem is ambiguity. Okay, so this is the grammar which is the example for ambiguous grammar. Okay, so almost the time is over. So see here, just to remember this. Sometimes they won't give any production rules in your exams. They just give the statement as prove that a grammar is ambiguous. Okay, for this case means you have to write the production rule. Very simple. You have to remember this is the only product. This is the two production rules there. S tends to S, B, S or A. So this is the problem for example of the grammar is unambiguous. Okay. So it's almost the time is over. I think which is unambiguous or ambiguous. Let me see on the next class. Actually, this is the unambiguous grammar. Sorry. So this is the unambiguous grammar. Okay. So this is so you have to remember this production rule. Okay. So this is for again one more. This is for again example for ambiguous grammar. So unambiguous grammar which is here. This is one thing. Okay. So the time is over. Okay. So I will see you on the next day session. Thank you, students. I think is it my voice is audible with full day session. Okay, thank you, students.